The comparison between VY Canis Majoris, referred to here as VOJU, and other red supergiants reveals an object in the universe that defies conventional explanation. With its enormous diameter, irregular pulsations, and unpredictable behavior, this red supergiant challenges scientists' understanding of stellar mechanics. It is an enigma that continues to baffle researchers, who are still trying to fully grasp the scope of its power, its internal processes, and its ultimate potential. As these scientists investigate this magnificent star in greater depth using advanced instruments, they have discovered something truly terrifying and equally awe-inspiring. Join us as we embark on a fascinating journey through the constellation Orion, guided by the piercing eyes of the James Webb Space Telescope. This expedition is not just a casual stargazing venture. It is a deep dive into the mysteries of a star that might fundamentally shift our understanding of the universe, of stellar life cycles, and of cosmic evolution. The arrival of advanced observatories like Webb has opened doors into the heart of the cosmos, offering insights that were once out of reach. If you are intrigued by cosmic events and the evolving universe, stay with us. Subscribe to our channel, give this video a thumbs up, and make sure to turn on notifications so you don't miss a single update from space and beyond. Although many people are unaware of this remarkable fact, it is entirely possible to spot Betelgeuse, often referred to here as B Rouge, with the naked eye during winter months in the northern hemisphere. Just look up at the night sky and direct your attention toward the constellation Orion, along with the neighboring constellation Canis Major. There, you can observe this dazzling reddish-orange star shining with a distinctive glow. It marks the upper left corner of Orion's rectangular shape. Its brightness and hue make it one of the largest and most prominent stars in the night sky, nearly impossible to miss. However, those who have observed this star closely over time will have noticed that it doesn't shine with a constant light. In fact, it varies in brightness periodically, sometimes quite dramatically. This peculiarity is no mere coincidence. Betelgeuse, or Vito Rouge as it's called here, is far from ordinary. Though it might appear to be just one more bright speck in the vast firmament above, it is located at a staggering distance of over 640 light-years from Earth. At first glance, this number may not seem particularly daunting. However, in cosmic terms, it's a monumental span. To put it into perspective, imagine traveling at the speed of light, an incredible velocity that is theoretically impossible with today's technology. Even at that unimaginable speed, the journey would still take more than 640 years. Now, consider undertaking such a voyage in a spacecraft using our current most advanced propulsion systems. It would take over 12 million years to reach Betelgeuse. That figure far surpasses the entire recorded history of human civilization. But the dim appearance of Betelgeuse isn't just the result of vast distance. Its flickering light is also tied to its unique classification as a pulsating red supergiant. This means it is an ancient, massive star that undergoes dramatic expansions and contractions over time. During these pulsation cycles, the star's brightness changes, making it appear more or less intense in the sky depending on its current phase. These brightness changes aren't random. They follow patterns, albeit complex ones, that span periods ranging from tens to hundreds of days. What's truly fascinating is that Betelgeuse can fluctuate in brightness over a very wide range. It can shift from a near magnitude of 0.5 to a full 0 magnitude, rendering it extremely luminous in the night sky. These cycles include a short one of approximately 185 days and a much longer one that spans around 2,335 days. At certain times, such as in February 2021, Betelgeuse dimmed dramatically, reaching one of its faintest recorded magnitudes of plus 1.614. Though still visible, it was notably less bright than usual, leaving observers and astronomers astonished. Yet brightness is just one of this star's remarkable traits. Betelgeuse is easily recognized for its distinctive reddish color, which is attributed to its relatively cool surface temperature. Unlike our Sun, which has a surface temperature of around 5,500 Kelvin, Betelgeuse burns at a much cooler 3,500 Kelvin. This lower temperature means the star emits significantly less energy per unit area compared to our Sun. As a result, despite being one of the largest stars we know, it appears much dimmer than it would if it were hotter. In a poetic sense, Betelgeuse is like a gentle giant, massive in scale but content to glow softly rather than blaze brightly. Do not be deceived by its muted glow, however. Betelgeuse is a true supergiant. It possesses a mass approximately 20 times greater than that of our Sun, making it one of the most massive known stars. This immense size and mass are part of what makes it so compelling to astronomers and astrophysicists. For centuries, It has dominated the night sky and even drew the attention of ancient Greek astronomers like Ptolemy. Its name, derived from Arabic, translates roughly to Orion's armpit, reflecting its position in the constellation. While ancient astronomers could only observe it with the naked eye, modern technology has provided us with powerful tools to study Betelgeuse in intricate detail. Telescopes such as the Hubble Space Telescope have captured incredibly detailed images of its surface, revealing swirling clouds of gas and dust. These observations have enabled scientists to develop sophisticated models to better understand the star's composition, behavior, and potential fate. Additional studies have come from instruments like ALMA, the Atacama Large Millimeter Submillimeter Array, located in Chile. This state-of-the-art observatory has produced high-resolution images of Betelgeuse's surface and surrounding envelope, offering insight into the star's structure and atmospheric behavior. One of ALMA's most groundbreaking discoveries is the presence of a massive plume of gas extending outward from the star's surface. Scientists believe this plume is a result of the star's pulsations, caused by convection processes where hot gas rises and cooler gas sinks, creating waves that ripple through the star's atmosphere. Hubble has also provided its share of revelations, mapping Betelgeuse's surface in detail and exposing intricate patterns of gas dynamics. Among these discoveries are dark, cool areas on the star's surface known as starspots or magnetic spots. These regions are cooler than their surroundings due to strong magnetic fields that inhibit the normal flow of gas from the star's interior to its outer layers, effectively creating a chilling effect. These dark spots appear significantly dimmer than the rest of the surface and are signs of powerful magnetic activity. Betelgeuse's magnetic field is thousands of times stronger than that of the Sun, and this intense magnetic force shapes the gas on its surface into loops and arcs, forming visible star spots. What makes these spots especially intriguing is their size. Unlike sunspots, which are small in comparison to the Sun's total surface area, Betelgeuse's star spots are several times larger than Earth and can cover up to 20% of the star's entire surface. This scale and number far exceed what we observe on our own Sun. These massive star spots play a major role in the star's brightness fluctuations. As they rotate into and out of view, the star appears to dim and brighten accordingly. Because the spots emit less light, their movement significantly impacts the observed brightness of the entire star. These fluctuations are further amplified by the star's pulsations, making Betelgeuse an ever-changing celestial beacon. Despite its extraordinary qualities, Betelgeuse is not entirely alone in its behavior or characteristics. There are other stars in the universe that share similarities with it. One of its closest cosmic relatives is Antares, a red supergiant in the constellation Scorpius. Like Betelgeuse, Antares is a variable star, which means it too experiences changes in brightness over time. Antares has a mass about 12 times that of our Sun and a radius approximately 700 times larger, making it a formidable stellar object in its own right. So, with all this complexity, magnitude, and variability, one cannot help but wonder, has Betelgeuse already exploded? Given its life stage as a red supergiant, it is a prime candidate to go supernova. But because it is so far away, the light from such a cataclysmic event would take centuries to reach us. It's entirely possible that the star has already met its explosive end, and we're simply waiting for the signal to arrive. The idea is both haunting and exciting. Only time, and light, will tell. As we press further into the cosmos with ever more advanced observatories, the story of Betelgeuse, or as this narrative refers to it, Veau or Vero Rouge, comes into sharper focus. Scientists are piecing together the star's history, behavior, and fate with increasing precision. What began as an intriguing outlier in brightness has transformed into a rich case study of stellar physics, magnetic phenomena, and cosmic evolution. One of the most fascinating recent developments involves the refinement of Betelgeuse's distance and size estimates. The star's radius, based on observations and models, is now believed to be between 700 and 1,000 times that of the Sun. At its largest, it would encompass the orbit of Jupiter or even Saturn if placed at the center of our solar system. These measurements owe their precision to instruments such as the Very Large Telescope Interferometer, VLTI, in Chile and ALMA, enabling astronomers to resolve tiny angular dimensions despite the immense distance. The distance to Betelgeuse remains a topic of ongoing refinement. Parallax measurements from ESA's Gaia mission have improved our estimates but continue to carry uncertainties. Current figures range from about 640 to 670 light-years, but even that narrow variation can translate to significant differences in calculated luminosity, radius, and mass. These seemingly minor refinements bear major consequences. A larger radius suggests a more tenuous atmosphere, a smaller distance might forecast an earlier supernova. Every decimal point matters. These observational refinements have been complemented by increasingly sophisticated three-dimensional models that capture the star's convection, pulsation, and magnetic dynamics. High-resolution simulations now depict Voju's surface as a roiling cauldron, with giant convection cells, some the size of Earth, cocooning within its extended atmosphere. These cell boundaries shift and dissolve over months, hundreds of days, and even years. They cause brightness variations both directly and indirectly, by modulating mass loss events and magnetic interactions. One mechanism generating public and scientific fascination is how these convective motions can trigger episodic mass ejections. In December 2019, Betelgeuse dimmed substantially, a phenomenon known as the Great Dimming, followed by a partial rebound in 2020. Theories emerged that this was caused not just by surface cooling but also by a massive dust cloud blown out during a convective upwelling. Multispectral observations across infrared, optical, and submillimeter wavelengths confirmed the presence of fresh dust near the star. The dust cooled and absorbed light, reducing brightness in our eyes before dispersing. The event showcased how convection, pulsation,